All right, welcome back to our series where we're trying to implement a compiler that is compatible with CA Clipper in Rust. And this is our fifth episode, so I wanted to take a little pause and try to reflect on how we've been approaching this project so far. And I created this little diagram here, so you can imagine that each of those boxes are the different components that we have on the system, right? And we created all of them so far. So the approach that we had here was to expand horizontally, right? So we could face all the components and see the complexities of each one of them. And now the idea is to start making them a little more complex, right? In a way of creating more coverage for the language, right? And that's what we're going to start doing today. We're going to go all the way back to the lexer and start to add more variants to the lexing tokens. I already started the process since it's very tedious. So if you go to the lexer here, you see that I added a lot more tokens. I think we had everything up until close parens here. And the reason I started doing this is so that we could start implementing the binary operations and the unary operations. So I think we're going to start with the unary operations. So I had to add all of those tokens here. And another thing that I had to do was to sort the tokens from the larger regular expressions to the shorter ones. And this is because imagine the following, right? You have a token here that is equals, right? So if I don't start with this one that has 2 characters, I would assume that this token is 2 equals, right? So I also implemented the change. So if you look here, let me see what there it is. I think it's on the tokenize. Yeah, so here is where I'm doing that. I don't know if you guys remember, but we used to do the iteration here on the token.iter, on the iterator of the token. Now I create this all tokens thing that is basically the same thing, the iteration of them, and then I collect them to a vector in a way that I can then sort them by key. So I sort them by len, right? So the shorter it is, the higher it's going to be on this vector. And then when I'm iterating through this guy, what I do is I do the reverse, and then everything works. And in order to make sure that everything was working, I created a bunch of small unit tests for all those binary operations here. So equals, greater than, and whatnot, right? But only, of course, only for the parsing, the lexing aspect of it. So where I want to start today is implementing the tokens for the unary operations, and then start doing the parsing for unary operations. And to figure out what unary and binary and other operators we have on the language, I went back to DOSBox. So let me open it here. Here it is. And so if we go here to capture, load state, and I remember that we have this little utility called ng. And ng is, I don't know how far back you guys go as far as development, but before the Windows days, you didn't really have multitask, right? So the strategy that programs had to offer some kind of multi-thread was to create what was called TSR. And that would be terminate and state resident programs, right? So this one here, ng, is one of those. So it basically sets a listener to an interrupt on the system, and when that interrupt is called, it starts working. So in this case here, you can see that you activate this with Shift F1. So if I press Shift F1, you can see that I get this amazing guide for the Clipper language, right? And if I press F9, we can go in full screen. So imagine that you had your editor, and then you would have, some sort of question about how to implement something, and then all you had to do was press F9, and then this would pop up. And it was pretty revolutionary for the time. And I know that today we take a lot of things for granted, but just wanted to say, this about this kind of tool and how we used to do things back in the day. And sure enough, if we go to language here and we go to operators, you see that we have this very comprehensive list of all the operators that we need to support, right? And I already did a pass with all the binary operators. So I think we have all of the binary ones. So what I'll start here is going through the unary operators. So in order to do that, what I think I'll do is the following. Let me make this smaller. And we're going to put it here on the right-hand side. I'm going to go full screen here, and I'm going to put the editor on the left-hand side here. Make this a little smaller so we can, you can stretch it. That's interesting. So we can start implementing those unary operators. So if we go to our list of tokens and we go to the end here, we can start from here. So we do strum props. Let me just turn off Copilot. and regex equals R, and then this is the ampersand, like this, and we can call this one ampersand. Is that how you say it? If it isn't, forgive me, I'll fix it later. Then let's see what the next one is. So you have unary. Which one is the next one? Increment. Yeah, so let's do that. Regex is gonna be, I think we need to escape because plus is a valid operator for the regular expression. And I forgot to add this caret here, like that. And then we can call this one plus plus, right? Regex equals, let's see what the next one is. We have the subtraction or the negative unary. We already have that, so we can skip it. So that, we have the decrement. Let's add that. So I think this one can be written like this, and then we can do minus, minus. Next one. Binary, binary, pass by reference. Let's add that one. Just like this. And how do you call this in English? I call it at sign. Let's ask our friend here, 1 second. What is the proper name for the at? No, I don't want at sign. Commercial at or at? Okay. So I was not that far off. Let's go back here. We're gonna call it at. Back to the DOS box. Let's continue our search here. And I think we're done. Are we? Let's double check. Yeah, I think so. Binary, binary. Most of those are binaries. Okay. Oh, and we have the logical not as well, which is unary, and I missed. So let's add that here. Let's actually add it close to the or and end. Let's add them here. Props regex equals not. All right, now I think we're done. Perfect. Let's write a couple of tests here for them. Then it's gonna call this one test negative. We already have for that one. So that's the how did we call it? Minus minus. Let's copy this guy here. Then let's do minus minus a. And then we're gonna have identifier now. We're gonna have minus minus. And it should have a. That should be it. Let's see. Yep, that's done. Let's copy this guy here. There we go. So the next one after minus minus is the not. Let's do not test. Not. We're going to do not a. Make sure that we have a not. Let's try it. Oh, what did I do? Okay. Let's do another one. So after not, which one did we have? Pass by reference. So same thing, let's delete everything to the A, add our at sign. Just like this. Let's test it. Then we can copy this guy, yank, and paste. So after at, we have pass by reference. Okay, so we did that already. Okay, I think we're done. Oh, I didn't do the send for binary, so let me do that. Let's add here. Do we have colon? We don't, right? No. We have colon equal. So let's add that to the end here. Strum props regex equals r colon It's going to be colon like this. And I don't know how this is used, so I'm curious. Let's see. So object and message. So that's true. So this is how you call a message method on a class. Interesting. I didn't remember that. So let's add that one here. So we're gonna test colon. And why don't we add that example here? So my browse page up. So for this one, we're gonna copy a previous example for let's put it like this, because this is a binary one. Not that it matters here, but I'm putting the same context as it would be, as it would have on a real program. So yeah, I think here is a good place, like that. And we can do identifier, my browse, and page up. Oh, what about those guys? We don't, oh yeah, we have them. Token, open parens, token, close parens. Let's try it. So what was the issue? Oh, I left $. Here. So the thing that I wanted to test, I didn't test. What? That's weird. Usually it reopens the file that I was editing. So let's go all the way to the bottom. And now this should pass, which it does. Yeah, so sorry about that. I had to restart my NeoVim. Something was off. I had to restart Tmux and the whole thing, but now it seems to work. So as I was saying, let's start by writing a couple of tests. So use super asterisk, and then let's turn off Copilot, and then let's do a test. And what we want to do is to parse a unary operator. Yes. So, and to do that, I think we can even grab an example from the Lexer. Like, let's get this one for now. And so now we need to do the lexing, and we do need to do the parsing. So let mute parser, parser new tokens. I think we pass it like this. Let me double check. I think we also need to pass the program. So, no, just the tokens, okay. Then let program is gonna be parser parse unwrap. And then we need to assert that the program, let me remember how the program works. So if we go to program, it has statements, all right? So let's do program statements vec, like that. And then so we're going to have a statement, and for now we only have expression, and this is going to be an expression unary, and then we have a unary operator, not, and an identifier a dot into, like that. And we close the expression, close the statement, and I think we're good. There it is. Okay. So let's, we don't have unary. The program does, okay, so a couple of points we have to, so make the program derive, debug, clone, and partial equality. And I see that we have a lot of derives, debug, clone. We're gonna change that to derive. Oh, let's do, yeah, let's do it like this. Let's be smart about it. So we can do this to be clone and then partial EQ, like that. Did that fix? Okay, now it's complaining that we don't have unary. So let's edit unary, and then unary is gonna have a unary operator and an identifier. Oh no, we have an expression, so An expression can be a constant. Yeah, we don't have strings yet. So this is a variable if we wanted to do that, but no. What I'll do is an expression. Var. Yeah. So that's exactly what I want. So not an identifier, we need a box of expression, and we're probably gonna need to box the guy on the left-hand side. But before we do that, let's do the derive here. So let's do this. This, and then pub enum unary operator, and we're going to add not. Okay. So here, let me import the lexer. And of course, we need to, as I said, box this guy. There we go. What else do we have? Oh, we have two partial EQs there. So, do we have any others? No. And then we have a non-exhaustive pattern here on the emit. So let's let's go to the top here and generate the missing arms with to do. That's fine. Very not. Yeah, that's fine. Okay. So now, if we go here and do a test of this, this is going to fail. We can see why it fails. Expected expression found not. So we can see where we do expected expression found that. Okay, so if token dot is, now we need to parse unary. So let's do self dot parse unary like this, and then thinking. So let's just do like this for now, and let's create the parse unary. I want to pull it a little further up where we have other parsers here. Okay, so here we can do if self.peak token. Maybe we can do is unary self.peak token. And for now we can do a function here, is unary token. And we can return token is token not for now. And we can make this more complex after. So if it's unary, we're going to do self.expect token not. And we can return. Yeah, this guy can probably return an option of unary exp unary. So here, if it's, maybe we can do it better in, no we can't. So if not is unary, we return none. This way we exit early and we make our code a little cleaner, in my opinion. So like this, and then of course we do OK, exp unary, then unary not, unary operator not, and self.parse expression like this. Yeah, of course this can fail, so we're going to have to return a result. But before that, we need to do box new, because we're putting an expression inside another expression. We don't need this. We're missing one of those. And let's see, 10K here, anyhow, result, like that. Returns a bool. Actually, I think we can do match self.peak token. And we don't need this. And we can do let operator equals match token. And then we can have token not. We return unary operator not, like this. Then if it's anything else, we return none. Actually, maybe we need to return an error. Yeah. So we're gonna do the following: return anyhow bail expected unary operator found like that. And then we don't need the option here. As type option, Lexer. Yeah, so sum. Yeah, that's right. We can't do it like this. And then we need to just do, I'll get there. Let's do unary operator. Then self has to be mutable. That's right. And then we need to handle the error here. And now we're good. All right, let's go back to our test. Let's see. Let's test it. Okay. Parse unary. Okay. We're not going to have this anymore, at least for now. Well, here it doesn't matter which token it is. So let's go back to our test. Okay, we have more issues here. Found an identifier. I think we forgot to consume the, let's see, 161. 161. Oh, okay. So here, let's go to parse unary. So here we can do next token, actually. And then here we can do that, and here we can do token. Token. Oh, we can even do better. We can do sum token. And then if it's nothing, if it's none, we can do anyhow bail expected unary operator found end of file. Why doesn't bail like gets out of it, returns early? Doing something wrong. Maybe if I do return anyhow like this. But that's what I thought bail would do. But okay. Okay. Let's try it again. Still no. Yeah, we're on the same error still, so let's go to parse unary. So we're now consuming the operator. We don't expect it anymore, my friend. So now I think we're good. Let's see. Still no. Same error. Expect unary operator found identifier A. That's odd. So let's see. Parse unary. Let's see if it's reaching here. I think it is. Creating unary with operator. Let's actually go here and cargo test. Parse unary, no capture. Parse unary. Oh, test parse unary. Let's see. Test not. Let's call it test Or even better, let's call this unary not. Expected, oh, so we didn't reach. Interesting. Okay, let's go to parse unary. Oh, it consumes the next token. Okay. I think we need to peek it here. So if it's an identifier, we'd consume it. So take token, consumes identifier. If it's an int, we do the same thing. Self dot take token, consumes int. Then if it's something else, yeah. Oh, big token can fail? Interesting. There and there. Mismatched type token found. What the heck? Did we just reintroduce this? Okay. There we go. Now our test passes. Let's go to the next one. And if we take a look at our list, the next one, yeah, I think a natural one to do next is AND. So let's go to unary operator. Let's do AND and parse unary sum token and unary operator and what else do we have? Let's check our list. We have the unary positive. So sum token plus unary operator positive, sum token minus unary operator negative. What else? So decrement token minus minus. Oh, let's do plus plus to keep the order. So our OCD doesn't get triggered. Unary operator. And this is going to be increment. Do we have that before and after? Let's see. Yes, we do. So we're only doing the prefix one. Sum token less less. We're doing unary operator. Do we want to do prefix and postfix? Maybe we can do prefix increment. Yeah, I think we'll need to handle postfix after. Increment and decrement. So let's rename this to parse unary prefix. And I remember we called this minus minus. So binary, 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 unary. We did this one. Binary, 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 binary. Pass by reference. Let's do that one. Sum token at unary operator ref for now. And I think that's it. Okay, so let's make all of those. Generate variant, generate variant, generate variant, generate variant, and generate variant. And we have them all here. Very nice. Okay, now I think we can do the binary operation. So let's create a new test for binary add, and we can do something like 2 plus 3. And we're going to have a binary expression, binary. We're going to have box new expression constant 2. We're going to have a binary operator add, and then a constant 3. This is a comma and 3, and this is a comma. There we go. Let's implement binary. So binary box exp binary operator and box exp. Like this. Let's add the binary operator. Pub enum binary operator. And this is going to be add like this. So we have an issue here because let me save this. Oh, I think I know what it is. Yeah. We're missing a binary operation here. Let's go to our test. Let's see if we can run it. There was an error here in our NeoVim, but yeah, you can see here that it parsed as a constant and then a unary expression on the positive. Yeah, I thought it was an isolated 2 and then +3, right? Let's see how we can fix this. I think the way that we're going to have to start handling this is to go to the parse expression. And we're going to have to parse a left-hand operation. So let's do let mute left equals self.parse left hand side like this. So hs mute self anyhow result exp. And I think we're going to have to do and extract what we had here to the left hand side. Let's see. Let me take all of that out. We're going to put it here. And then if it's an identifier, we can, I think, return this. Oh, no. Let's do like we were doing there. So we can have an OK exp here. So here, in order to differentiate a single expression from the binary expression, I think we need to do something like if let's sum op equals self.parse binary operator. Something like this. We're going to handle binary expression. Otherwise, we can return left like this. So right hand side equals self.parse expression. And then we can do return OK expression binary box new left operator and box new let's call it right, but let's do the right hand side here like this, but just let's rename this to right. This is parse exp, parse left hand side like this. Let's introduce parse binary operator. Mute self, and this guy returns an anyhow result of an option of binary operator, and then match self.next token like this, and then if it's a sum plus token plus, this returns a sum binary operator add, and I think that's the only one we had so far. Yes. And then otherwise this is a none like this. Let's see. Try wrapping in an expression. Yes. Let's do OK. We can do it like this. Let result equals this and OK result. Okay, this guy doesn't have to be mutable. parse left hand side, self peak token. We don't consume the token here. Take token. This needs to be mutable, no? Yeah. So I don't get it. Oh, but we're never mutating left. Yes, that's right. And self is already mutable. Okay, let's see how that... Oh, we have an error still? No, we don't. That's from the test. So let's do like cargo test, and then how did we call it? Binary addition, was that it? No, binary add. Premature end of file on line 210. Oh. Rust backtrace equals 1. Let's see where that's happening. We actually don't need to. Premature end of file, here it is. So we were doing a take token, but that's, so that would be line 142. Let's take a look here. So we're doing take token on 144, and we are in parser 138. 138. It's on the next token. Let's see. Where were we? So 138. Parse binary operator. Okay, in line 38. 38. Okay, so this was an end of file. Yeah. We have to do a peak token. Not an... Whoop, yeah, peak token. Peak token. That's an option token. We don't need to do this. Then if res.is sum, we consume the token, so self.take token. Like that. What happens if we try it this way? Oh, it works. Very nice. So yeah, we have it working. Okay, so now let's create a sample program. Let's go here. Let's add a operators. How can we call this? I want to test both the binary and the unary operators. Operators.prg. So let's do the following. And var1 is going to be 2 plus 2, and var2 is going to be 10 minus n var1. Then n var3 is going to be minus n var1, and n var4 is going to be plus n var2 or something like this. Let's save it. And if we try to cargo run samples operators.prg, what do we get? We get at least an AST. So let's see. Let's put them side by side. I think it's a little bit better. Let's see here. So we have assignment for n var1 of a binary of two constants, addition. That's pretty cool. Expression n var2, that one fell short because, yeah. Okay, let's handle that. Let's go back to our program. Let's go here. And let's create another test exactly like this one. Okay. Yank, paste, there we go. So we're going to call this one binary. Which one did we have that failed? This one? And we expected this to be an expression and an assignment. So expression assignment of var? No. Is it expression variable? Yes. Is it? Let's see. Yes. So this is supposed to be n var2 into then the binary of constant 10. Then here oh, we don't support minus yet. That's the problem. Minus. It's good that I came to write this test. Var and var1 into, like this, close the binary, and close the assignment. Is that all we need? Yes. So let's go to, what's the problem here? Yes, this has to be boxed. So box new, just like this. Unboxing the value. Ah, man. Yeah. So what needs to be boxed is the assignment. So box new. Let me just make sure assignment. Yes, so it's two boxed operations. Oh, expression rather. Okay, let's go to binary operator. Let's add minus. There we go. Let's run this test. Oh, this is binary add. No, this is binary minus. Or binary take. How do you call this? Subtraction. So let's call this subtract, like this. Then if we test it, what did we get? We still get var2 constant 10, and then a unary. Oh, I know what it is. We didn't put it on the match. So parse binary operator. Yeah. We need to do sum token minus to subtract copilot disable. So let's rerun our last test. Let's go to binary subtraction. Oops. It's running. There we go. So nice. Let's do all the operations here. So add, subtract, multiply, and divide. What else? Let's actually get our little list here. I think this is way easier. So we have a comparison, substring comparison. I don't think we're going to handle that now, but let me add it here. Substring comparison. We have modulus, unary, binary, multiplication, we got that. Exponentiation, exponent, unary, or subtraction, we got this. Unary, binary, alias assignment. And not, we don't have, or division, we got it. Send. Let's try to classify those close to each other. So exponent, we can put here, then and or. Same here. Modulus, we can add here. I think it's modulo, right? Then we have some string comparison, alias assignment, send. Inline assign, this one we handled already. Less than, less than equal, less than equal, not equal. Let's do the greater than here. And greater than equal. Then we had not equal. We did it this one. Simple assign. So we have simple assign. I'm going to put this one here. Compound assignment. Compound assign. Equality. We don't have equal. Equal. Not equal. This is unary, and I think we're done. Okay. So let me put those with these. since those are the ones we don't quite know yet how to handle. Let's save this. Okay. Now let's try to handle all of them. This is the time where we want to split this and leave our list here and go to our match on our processing. So parse binary operator. So we have minus. Then we have for multiply, it's going to be star, some binary operator, multiply. Then some token slash some binary operator divide, some token star star. It's going to be some binary operator exponent, and some token modulo is the caret. What's the modulo? Let me see. Modulo. It's the percent. Where is it? Here. Oh no, it's modulus. I'm gonna leave it at modulo. So percent, some binary operator, modulo, which I think is the remaining of the division. Okay, did it do them all? Not even close. Some token and. It's going to be some binary operator and some token or. Then some token less. It's going to be some binary operator less than some token greater some binary operator greater than. I think we have some token less equal some binary operator less than equal some token greater equal some binary operator greater than equal some token. And this is a funny one because there are multiple ways of saying not equal. So can you see? This is illustrates how the not equal operator behaves with different data type. But I think they are all interchangeable, those three versions. So if it's less greater or some, how did I call it? Did I have this one? Let's see. I think I may have missed it on the Lexer. Where is it? Tokens. So we have greater equal. We have less. I think we have a hash as well. 0% hash. So I'm going to also add that one that I missed. Props. It's going to be not equal. Oh, we have that. Bang equal. Here it is. Okay. Bang equal. Or some token hash. I'm going to do some binary operator not equal, like this. What else? So not equal, and we have those 5 here, simple assign, that I'm not going to implement right now. Implement those. Bang. There we go. And now what happens if we try to run, let's see, we have assignment, binary, unary for this one. Interesting. Why are we not? Oh, yeah, we should have been catching this. So we did the two first. Let's see here again, operators. So we did this one. We did this one. This is unary. That's correct. Unary, yeah, negative nvar1 and negative nvar2. There we go. So I think I'm going to stop here. And on the next episode, we're going to get the binary operator and unary operator and propagate them through all of the layers. If we go back to our little diagram that we had here, what we finished so far for binary and unary operators is the lexer and the parser, right? I want to advance it through the IR generation, create the assembly, and finally to the code generator. So we can start taking a look at those. So we can have example programs that have an exit code here. Imagine you can do like error level and var4, and then you expect it to have the result of all those operations here, right? Does that make sense? All right. Once again, thank you for watching, and I see you on the next one.